So today, what we're going to be going over is identifying domain and range from either a graph or a table or a mapping. I think it's pretty straightforward. I kind of have skipped a lesson that I think I can sum up very quickly. So what I want to do at the beginning is talk about the lesson I skipped because I think it's kind of boring. But hopefully I think you can pick it up pretty quickly. So the thing that we are kind of skipping over is the difference between a discrete function versus a continuous function. So what do you think it means if a function is continuous?
It's never ending. Keeps going.
It's never ending. There's no gaps in it. So remember when we were looking at the number of campers that were available at that kids camp. The campers were 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Was it the numbers between them? No. Did it go on forever? No. So there was a countable number of campers. You could count them. That's discrete. When I think discrete, I think countable. Another word that people might use is finite. You guys know what a finite means? What does finite look close to? Like infinite. So what does the prefix "in" mean? Let's get to some English here. If you are indecisive,
Oh, you can't decide.
you're not decisive. If it's indeterminate, can't be determined. Inconclusive, not conclusive. Indefinite. Can y'all think of any prefix "in"? Independent.
Incredible.
That's a bad one.
Indivisible.
Indivisible. Not divisible. So what's the prefix "in" mean? Not. So what do you think finite means? Look what's above it. Look what's above finite. So finite means countable. Infinite, not countable. Infinite, infinity. Yeah? A little English. Okay. So if discrete is countable is finite, then continuous would be uncountable and infinite. So the number of campers, would that be discrete or continuous? Discrete. The temperature that it could be outside. Right, so that's where you get into, that could be an argument you could make. The deal is, though, if you think about the temperature, could the temperature be 28 degrees?
Yes.
Could it be 29 degrees?
Yes.
Could it be 28.5 degrees?
Yes.
Could it be 28.2 degrees?
Yes.
So could you count all the different temperatures between them? You can't. So it would be uncountable, the different number of temperatures that there are. What was another example that we had on Friday?
The square root, find the square.
Side lengths of a square. So even though it's not all real numbers, because you can't have negative, square lengths can be as big as you want them to be. So that graph would be continuous. Okay, so the difference between continuous versus discrete. I think you kind of got an understanding. You've got a good enough understanding that that's all you need in Algebra 1. Okay, so I'm fixing to hand out these worksheets. We'll look at them. I want you to notice everything on the front is a discrete function, which means you can count all the points, all the elements. On the back, those are all continuous functions because you couldn't list all of the elements in the domain and the range. Remind me, there are 2 papers.
Yeah.
I'll forget.
It's when you give them
So when you guys look at the side that's listed discrete, do you understand why all those functions would be considered a discrete function?
They're all counted. They're not very large or low.
Right? Like, on number 1, how many elements in the domain are there? Can you list all the elements in the domain for 1? Well, so just to review, what is a domain?
Any x value,
The list of all possible x values. The range,
any y value.
the list of all possible y values. What's a function?
A special relation where every input is exactly one output.
Special relation where each input has exactly one output. So, if I'm looking at the domain was all possible x values. What would the domain be here? -5 is an x value. -2 is an x value. 0, 3, and 6. So is that a countable number of x values? That's why this is discrete. It's countable. It's finite. Everybody understands that? So here's how we're going to write the domain. We're going to put it, I'm not going to be as strict as I was last year, but I still want some of the makings of set notation. So in order to do set notation, you need to start with a brace. It looks like that. I had to learn how to draw it. You see, it took me, I had to draw it twice on it. Like that. It's a brace. Big loop, little V, big loop. But there's this little thing too. When we list the domain, they need to be in order from least to greatest. So what is the smallest element in the domain? -5. What's next? Next.
0,
Next.
3,
Next.
6.
That's my domain. So when you list the domain of a discrete function, you literally list all the x's. Just list them. Because it's countable. The smoke detector in the second story chemistry lab is unusually dirty. And that thing beeps every time.
Unusually dirty.
You know, about once a week that alarm will go off and let us know. So if you guys ever visit the chemistry lab and you want to do me a favor, clean the smoke alarm. Or if you have a chemistry teacher, tell them, hey, I don't know. I just know that that's what that says. It just says the smoke detector in the chemistry lab, second story chemistry lab, is unusually dirty. So it's a safety hazard. And it beeps until we acknowledge it. And I have to acknowledge it. Okay. The range is the list of all possible y values. Guess what? It needs to be listed in order from least to greatest. So what's the smallest element in the range? Next.
-14.
Next.
-8.
Next.
1,
Next.
10.
Any questions about identifying domain and range of discrete functions? Well, it looks like not everything is a function. It says discrete functions, but as I'm looking, they're not all functions. So here's one thing that I want to mention. In the domain and range, make sure everybody's listening. If there's an element that happens multiple times in the range, you only list it once when you actually list the range. Remember in our mapping where I told you sometimes you'll only write that number one time? And you'll draw multiple arrows there. Same thing in domain and range. So if the element, I don't even see one. Let's just make one up. if this, number 3, had another ordered pair that was at 7, 1. Notice how the output, the y value 1, happens twice. When you list the range, you only list it once. Don't list it twice. So I want you guys to try the front page, see if you've got enough information to identify domain and range, and then we will go over the answers. I gave you that whole spiel about, yeah. So, if I look at number 7, let's think about what's its domain. Well, it looks like there's a point at -2. Does the x value also go to -1?
Yes.
Yeah. What about -1.5?
Yes.
-1.75?
Yes.
-1.9, -1.91, -1.98. Hey, you think we want to list all of those x's in the domain? No, we have to list everything that's in the domain.
Be like 1 through.
Every number between 1.
Right, but we don't want to actually list them all. It's no. Slope has nothing to do with the x values. Slope is all about rise over run of a line. And the problem is some of these graphs aren't even lines. So if I look at number 7, let's think about it like this. What is the lowest x value the graph takes on? The lowest x value. The lowest x value. -2. So what you're saying is the graph doesn't go any farther left than -2. Do you guys agree with that? What's the highest x value the graph takes on? 4. So you're saying it doesn't go any farther right past 4.
Yep.
Does the x values include everything between those two values? Yeah, are there any x's that we do not touch between -2 and 4? No, we include every x. So here's how we say that. The domain goes from -2 to 4. So -2, 4. It includes -2. So we put a bracket around -2. It includes 4. So we put a bracket around 4. So let's talk a little bit about when we wouldn't put a bracket. So let's just play pretend, and let's say that here at the end of this one, I had an open circle at 4. You see how it's a closed circle right now? It's a filled-in circle. Let's pretend it was an open circle instead. So then what x values does the graph take on then? Well, it still goes from -2 to 4.
But then it keeps going to.
No. It includes -2, but an open circle at 4 means the graph never actually gets to 4. We get as close to 4 as possible, but we don't actually touch 4. You guys understand that with an open circle? What we do to show that when we list the domain is we put a parenthesis instead of a bracket. So a parenthesis means we don't actually touch that value. We get all the way up to that value, but don't include that value.
So like number 9.
Is there? Yes. See how there's an open circle on 9? So what would you guys say the domain is for number 9? -2 to 4. Is -2 included? Yes. Is 4 included? This is called interval notation. So what I want you guys to do is I want you guys to find the domain, only the domain for the other ones, 8, 10, 11, and 12. So we're not doing range yet, only the domain. Okay, number 8. What did you guys get for the domain on 8?
Negative 2 to 7 in brackets.
Negative 2 to 7, both in brackets. That'll be correct. Questions on 8. Now let's do the same thing with the range. Okay, so if I had to do the range for number 7, I want to think Y. So start at the bottom of the graph, working my way to the top. What's the lowest Y value the graph takes on? Does it ever go lower than negative 3? No. So the lowest Y value is negative 3. What's the highest Y value the graph takes on? 4. Does it ever go higher than 4? Are there any Y values the graph skips between negative 3 and 4?
No.
Like negative 2. Does it ever touch negative 2? It does right here. Does it ever touch negative 2.5? It does. So are there any skips? So like negative 1 is here. 0 happens in 2 places, and 2 happens in, but there are no Y's that are skipped. Do we follow? Every Y between my 2 purple lines is touched at least once. Therefore, the range would be from negative 3 to 4. Both of those in a bracket. What about number 8? Thinking about the range. What's the lowest Y value the graph takes on? Negative 3. What's the highest Y value the graph takes on? I think that's 6. I think it's 6. It did kind of like a 4. So I think that one's 6, if I count them. Does it include every Y value between there? Like, do you see any gaps in here? No. So it touches every Y between them, including these Y's. So they're in brackets. Okay, try the last 4. Okay, what did we get on number 9 for the range? It's from negative 3 to 3. So look at the highest Y value at 3. Does the graph actually ever get up to 3? No, because there's an open circle at 3. So it goes all the way up to, but not including 3. That's why this 3 has a parenthesis. Okay, we're now doing the domain for number 10. So what's the lowest X value? What's the highest X value?
Do you also not put 4?
No, it'd be infinity.
No, in interval notation.
I didn't know you put both.
0, is that a parenthesis or a bracket? Infinity.
It's a parentheses.
Infinities are always parentheses. It can't actually get to infinity. Okay, what about 11? What's the lowest X value the graph can take on? It is negative infinity. That we cannot see it visually going farther left than negative 4, but this arrow means it continues like this forever. So it goes all the way, and this is a hard concept when people first start. It's all the way over here, as far left as you want to go. What I compare it to is the graph goes all the way up to positive infinity. So what's another way we could say this besides negative infinity to positive infinity? You can't just put infinity, because that's not an acceptable answer. It either has to be an interval notation like this, or you could say all real numbers. That's acceptable.
Isn't there a sign for all of them?
There is. So the symbol for all real numbers is like a bolded R. That means all real numbers. So you put basically like you got two backs on a capital R. That's what this symbol is. And that means all real numbers.
Oh, okay.
So it's like this is bolded. If you see it in textbooks, this is normally filled in. But when you write it with a pencil, you write it like this.
I put an S for the R.
Okay. And 12. What would be the domain?
You can't see the same numbers.
Right, you can't see the numbers, so let's count them. -1, -2, -3, -4, -5 is the beginning. Where does it end at? 6. -5 has a bracket. 6 has a parenthesis. Any questions about domain? Get in your head, domain, you're thinking left to right. Reading it like a timeline. Okay, if I look at the range for number 10, what's the lowest y value the graph takes on? What's the highest y value the graph takes on? So this arrow means the graph continues forever, and it is growing, but just barely, right? The y's are going up, but it's okay. They're going to go up forever, right? Just very slowly. So the highest y value is infinity. Does it touch 0? So 0, should that be included? What about infinity? It's always a parenthesis around infinity. What about 11? What would be my range for 11? -3 is the lowest y value. What's the highest y value? Infinity. And -3 is to get a parenthesis or a bracket.
I mean, bracket.
And infinity.
Parentheses.
Questions there? Okay, what about 12? I'm interested in 12. What's the lowest y value?
-6.
It is -6. What's the highest y value?
3.
Looks like it's 2. What do they get? -6 gets a bracket. 2 gets a bracket. Is everybody good with all that? Y'all all got that one? Y'all may be the best group I've ever had at domain and range. I'm being legit. If you guys all got that, like everybody, nobody's lying. Everybody's on board. Am I just that good at teaching it now?
Oh, yeah.
A lot of times people put a parenthesis on 2. Okay? And that happens a lot. Why did you put a parenthesis on the 2? I know why. There's an open circle at the end of the x's. But think about the y value, okay? Think about the top that it gets. You see where I'm drawing my vertical line? Is there an open circle at the top at 2? So it actually touches 2. If I think about the y's, this is saying a y value of -2 has an open circle. But it already touches -2 somewhere else. And again, somewhere else. So it includes every y between there, including those. So open circles at endpoints only matter if they're the most extreme value. And so for the x's, that is as far right as it goes. But that's not where the height is or the lowest. Do we follow? And like I said, you're completely normal. That's what most people do. I bet you're not the only one in here. I'd say somebody else lied. Okay?